Welcome back everyone to the Atomic Islands, and today we are back here at the site for the periodic table, and today we are going to start actually building it. Our outer layer for this is going to be the cobblestone you see here. That will be our border, and that will go 256 blocks that way. And this is going to go 128 blocks this way, at least eventually. It's not quite that far yet because I still have that hill to bring down. That means this is going to be a long-term project. It's not going to be done in a single episode, and most likely I will break off of here once in a while, do some elements, then come back here and probably do a bunch of it off camera. But today we're going to be doing the first one, so we should do that on camera. So therefore we have the outer layer of cobble. Then our inner border is going to be made of sandstone, as you can see here. Some of it is the natural sandstone generated, but I also filled in a little bit to even it out. Then after that we have the elements border itself, because each element is going to have its own border, and those are going to be color coded. And I'm going to tend to put the alkalides, the ones on the left, are going to be red. And I'm going to have a rainbow shading going all the way down to the noble gases, which are going to be purple way down at the end. And each one is going to be 14 by 14. Now, you're saying, well, what is this? This is light gray, not red. And that's because the first element is hydrogen, and it's not technically an alkalide. It's its own category, so therefore I'm going to make it a light gray to indicate that it's not the same type as all the rest of them. 4, 5, 6, 7. What just happened there? I just thought I saw a chest close, which would have been rather strange to see at this point. 9, 10, 11, 12, 13, 14. I've gone through quite a number of shovels doing this thing. I'm probably going to have to do at some point get an enchanting station somewhere near here so that I can get some nice shovels. Let's see, let's do 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Alright. And I am going to have to dig this bit up right now, which means probably going to get myself another shovel. I removed all the sand, but left a lot of the sandstone because I don't need to remove all the sandstone yet, since I'm going to now be making my letters. And for my letters, I'm going to be using red sand for now. I may change my mind on that later on. And what I'm going to do is I'm going to make the capital letters 7. Actually, this is hydrogen. So that's, I was thinking about that. That's right, because in hydrogen is only one letter. If it were multiple letters, then the first letter will go here. But for the elements that have only one letter, I'll actually go in by 2. And then 1, 2, 3, 4, 5, 6, 7. So therefore this will be the bar of the H, and then we'll just have each of the letters this high. And then we'll just need to go down 2 by 1. And because I'm going to be filling in that part right there with sandstone anyway, which is why I decided not to take it all out yet, but there we go. And there is our H. So that gives us 1, 2, 3, 4, and 3 on that side. So that's about as balanced as we're going to get in that regard. There we go, H for that. But on top of this, we are also going to have down here a little indicator as to the, let's see, that will be actually right here, we're going to be having an indicator as to the atomic number, and that is going to be in binary of all things. So we'll just plop this here, and this is 10 wide. Now there are 118 currently known elements. So what I'm going to do is I'm going to plop one here. I'm going to remove that sandstone there, remove this sandstone here. Let's see, that's 1, 2, 3, 4, 5, 6, 7, 8. I'm going to have a marker color at each end there, which I'll show in a moment. And then here, I will have the whole thing in binary, with this being the 1's bit and that being the 128-bit, which we should never have the 128-bit on because there are only 118 elements. I'll use cobble on the two ends here, and brown for the center. There you go. Since hydrogen is element 1, that'll be there. And I think that's my definition. So let's see how this looks on the map. And there you go. Hydrogen, our first element, done. All we have to do now is 117 more. Yippee! The next element after hydrogen is helium, which is way down at the other end of the table. And since I want to avoid creating an entry for helium and then finding out I miscalculated and having somebody short in the middle, I am going to be going down the table first, which means I'm going to start onto the alkalides. And the first of these is lithium. 9, 10, 11, 12, 13, 14. Good. So I'll go around here, and as I said earlier, the alkalides are going to be in red because that's the left side of the table. And I will gradually update the color as I go down to base the color on the column up, though obviously some of them are going to be grouped together, especially, for example, the transition metals are all going to be grouped together since I'll treat them as one big block in there. Alright, there you go. There is our square for lithium. Now normally I would start the first letter here, but since the second letter is an I, I'll only be going in sort of a compromise between where I put the single letters and where I put most of the dual letters. So therefore put 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4. So the L should be fairly straightforward. 3, 4, 5, and now we could put our 2, 3, and of course room for a dot. How does that look on the map? Because that's where it's going to be important. Does it look like an L and an if I don't step on top of it? There you go. Now, what do I see? Li. Okay, good. And then we could put this on either end. Put in our cobble. We could put our brown terracotta there. Good, and that should take care of lithium element 2. Except, of course, element 2 is helium. Lithium is element 3. There you go. Whew. Our second alkalide will be sodium. So this one is actually going to be needing the full size that I was expecting. So let's see if I can do this. 1, 2, 3, 4, 5, 6, 7. So therefore I'm only starting with 1 afterwards. And then, well, making an N is going to be 1, 2, 3. Let's try this. Let's see how this, if we get this to look like an N, because that's the tricky bit for sodium, is to get something that looks enough like an N that it'll look like, at least when I look at it on here. Yeah, that can pass for an N. Alright, then let's get the A. Yes, sodium is one of those elements with the has a Latin-based, or I presume it's a Latin-based number lettering that's using on there. Let's see, 1, 2, 3. How do I do an A for lowercase a? Because let's see, we are going to do 1, 2, 3. So we got the 1. Let's see where I get something that looks like an A. If I could do this, I may have to expand it a little bit larger than I was expecting, but we'll see. 1. Well, that's not going to look good, so I'll give it a descendant then. And what happens if I make it look like that? See how bad it looks. What if I do it like that? Alright. And well, okay, I'll have to fill in the sides a little bit too, so we don't get those shadows in there, because if you get the shadows in there, then it makes it look a little strange. There you go. Alright, with that descent then that looks like an NG. I'm going to have to resort to a width of 4, which is actually not that bad, considering that I had that extra space I had anyway. So apparently some letters just aren't going to actually fit into the anticipated 3 for some of the lower, because the the uppercase letters, the first letter, I was going 7 by 5. For lowercase, I was thinking 5 by 3. And apparently not all letters work well with that. Now I was expecting a couple of descendants here, such as we'll be seeing with G and stuff like that. Let's see. Let's try it that way. Maybe without a descendant. Then we could see how that looks. Just stop standing on top of it. And looks like a sideways sigma. While seeking a solution on the internet to this, I was reminded of the alternate form of the lowercase a, and that actually looks reasonable. Yes. Using that form of the A, then that looks perfect. So that's what I'll use for sodium, is that one. And I've already filled in the binary there for 8 plus 3 for element 11. That's sodium. With the first two alkalides done, let's then try one of the alkaline earth metals, which is the first one we go into column 2. In this case, we will use orange for our border. So this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, good. We are counting it consistently. And hopefully it's consistently right. So therefore we have our orange border. And this we'll have another skip after this because we have a gap between here all the way down until we get down to the metalloids and nonmetals down at the other end there. So we will have this between episodes. I'll fill that one in. And after that we go down to the row where we start to get our transition metals, and that's when we'll do our first long one. And here we have lithium, so this one would be beryllium. So we'll need a B, so this will, of course, I think I could do a B more easily than I'm able to do a lowercase a, I hope. And the E that you get is also easy enough. For the B, I'll just try this, shaving off the corners there. Let's fill it in with sand to make sure that the shadows don't affect this when I look at it, because we know that's always been a problem. And this time I'll get well back before I... Yeah, that looks like a B. So we just now need an E. And the E is... He's going to look like an upside down A, pretty much. So you better be looking at it in the right direction if you do this, otherwise you'll have trouble telling your E's from your A's. It's probably one of the reasons why I was... Actually, let's do it by 4 and see how it looks, because I was thinking of originally doing it by... Right, because the A there... Let's see what happens if I do it as 4 wide instead of my original idea of doing it as 3 wide. Let's see. Yeah, I think I like that. So let's make that enough to fill it in with sandstone instead of the temporary sand. Now we know that's going to be sandstone no matter what, because I want to make sure I have don't have the artifact shadows that I will get when you have the things going down a little bit. There we go. Now let's have a look at this. Nice. And then that will be element 4, 1, 2. Okay, there you go. There you go. Now you can see the pattern of what I want there. There you have on the left side hydrogen, lithium, sodium, and then you have beryllium to the right there. And eventually the table will get nice and filled in. Now, of course, I don't want to show the entire building of this because that would be rather boring in there. So my thought then will be, for the next episode I will do one more segment of it, and that's the next line where we are going to have this to contend with. So you have to worry about a ravine. So this is probably going to be the greatest challenge of this entire thing, would be getting through here safely, because I have this ravine that I'm going to have to traverse all the way through, and of course we've got this sand topper here That's going to help to make it a little bit more of a challenge. Hopefully most of that is going to be sandstone, but I'm going to have to knock that down, and that sandstone is going to be disappearing, and I'm going to have to replace it with some other sandstone. So that's going to be the big challenge next time. And when I get finished, that will be with the transition metal, so that's going to fill things in to go all the way down to the other end. And once we do that, we could then curl up and take care of the elements that are going to be down near the village. But that's for the next episode. I think we did enough today. We've got 4 elements and a start to it. I am going to be filling in a few extra and knocking down a hill or 3. And we'll see how much I managed to do in the next episode of the Atomic Islands.